Hello guys, this is Manthan from Study Hacks and I'm going to take the subject automata theory, and the topic from my side is going to be grammars. So let's start with the presentation. Grammars. Okay, so what do you mean by grammars and why grammars? Okay, grammar in English language is used to represent certain rules and regulations. It is the same here in automata theory. Here, the rules is specified using a set of equations. For example, in English language, we have a rule that once the sentence is completed, we put a full stop. Similarly, there will be rules in the languages that we are going to define in automata theory. So, grammars are basically approach for representing languages through rules that is nothing but a set of equations. So that is all what we had to learn about grammar, and now we have to see how is the grammar represented in automata theory. So let us get to the first example. As you all have already learned about the finite automata, that is DFA and NFA. X here is nothing but a start state and Y is nothing but a final state, and thus there is a transition from X to Y over a symbol A, and this is the only transition in this language. So in grammar we represent the start state or the state by a variable or a non-terminal alphabet, and the symbol or the terminal alphabet over which the transition is taking place is nothing but a terminal alphabet in grammar. So the only letter or the only word that is satisfying in the language defined by this DFA and the grammar is A, that is X tends to A. So this is nothing but a variable, this is nothing but a terminal alphabet. Okay, the next example is this is X is nothing but a start state, Y is the final state, and there are n number of there is one transition over X over the symbol A to X. So you can have n number of A's in the language accepted by this DFA, and it must end via a B. So it must end with a B with any numbers of A at the start. So the corresponding grammar would be X. This is nothing but the start state, and even this is nothing but a start state. You can have no A's and only B in the language, or you can have X that is tending to AX. That is, this X can be again replaced by either this X or this X. If it is replaced by this X, then it will be AX, recursively AX, and you can have any number of A's, and finally you can terminate it with a B. So this was all about the grammar and the DFA comparison. Now let us analyze what we have learned till now. So a finite automata has a set of states, whereas a context-free grammar has a set of variables. Finite automata is defined over an alphabet, and in CFG we have terminal alphabets. So the alphabets and the terminals are nothing but the small a or B or C, or the symbols that are the symbols over which the language is based on. That is nothing but an alphabet or terminals. And finite automata is a set of transitions, whereas grammar is a set of equations. So this is nothing but a set of transitions here, and these are nothing but a set of productions or the set of equations. So this is what we learned about grammar. So we are ready to define grammar. As you all know, in automata theory we define the concept using tuple representations. So grammar is a 4-tuple representation with B, T, S, P, that is variable, the terminal alphabet, the start symbol, and the production. The variable is nothing but the capital X or the capital Y that we have already seen in the previous question. The terminal alphabet was the small a, small b, small c, whatever it can be, and the start symbol is nothing but the state from which actually the language starts. So this is nothing but X is nothing but a start state. And here we have X as the start state, and the A and B are nothing but the terminal alphabet. Okay, so yeah, so the finite automata is a set of transitions and grammar is a set of equations. That is perfect. So we did all that, and there's just one point to note down here is that the start state is always available in the V set. Okay, so it's like the v set is a superset of the start variable, because all the variables that are there in the grammar must be there in the v set, and s has to be a subset of v. So P is nothing but a set of reductions or equations. Okay, so this is all we wanted to know about grammar. In the next lecture, we'll be focusing upon the problems and context-free grammar. In this lecture, we'll try to build some grammars and get a better view about the grammar. Hope you all like the lecture. See you in the next lecture. Thank you.